Okay, so in this question we're given a function f of theta, and that's 4 cos squared theta minus 3 sine squared theta. And part A, that's going to involve identities, we just have to rearrange it. And part B, it's going to be definite integration and using by parts. So part A, we need to show that f of theta can be rewritten as half plus 7 over 2 cos 2 theta. So if you look here, so we have thetas at the moment, and the answer has 2 theta, so we need to use some identity. And there is an identity that we'll be using. Cos squared theta is identical to half plus half cos 2 theta. That allows us to double the angle, and also for sine squared, that will be half minus half cos 2 theta as well. So f of theta equals, so 4, and we replace cos squared with the identity. So half plus half cos 2 theta minus 3, and then we have a sine squared, so we replace that with this, half minus half cos 2 theta. And now we can expand the brackets, so we get 2 plus 2 cos 2 theta minus 3 over 2 plus 3 over 2 cos 2 theta, and then we can collect like terms. So 2 minus 3 over 2, that's a half, and 2 cos 2 theta plus 3 over 2 cos theta, and that's 7 over 4 cos 2 theta. And that's part A done. So part B, we need to work out the definite integral of theta f theta. So let's write that out. So the integral from 0 to pi over 2 of theta, and f of theta, we're going to replace that with part A. So that's half plus 7 over 2 cos 2 theta d theta. And let's just expand that out. So that's the integral. We can ignore the limits for the time being. So half theta plus 7 over 2 theta cos 2 theta d theta. Okay, so we can split this integral up. The first bit, the half theta, we can just integrate that straight away. And the second half will be an integration by parts. So let's do the first part first. So we're going to integrate half theta. And again, we're just going to ignore the limits and put the limits only at the end. So this equals a quarter theta squared, and we're going to ignore the plus c because it will be definite integration. So that's the first one done. Now the second one will be, let's just write that out, the integral of 7 over 2 theta cos 2 theta. And here we're going to use by parts. So the first product, let's put a u, a v, a du d theta, and a dv d theta. And the by parts formula is as follows. It's the integral of u dv should equal uv minus the integral of v du. So we need to fill in this diagonal here, and 7 over 2 theta will be the first product, and cos 2 theta will be the second product down here. So we differentiate this way to give us 7 over 2, and we integrate this way to give us a half sine 2 theta. Okay, so the integral equals uv, so that's this over here, so that's 7 over 2 theta times half sine 2 theta minus the integral of the other diagonal. So that's 7 over 2 times a half, that's 7 over 4 sine 2 theta d theta. So we'll simplify this term. That gives us 7 over 4 theta sine 2 theta minus this integral here. So sine theta becomes a negative cos. So we'll change that to a plus because minus minus is a plus. And we have to divide by the 2. So that gives us 7 over 8 cos 2 theta. And we'll ignore the plus c because it is definite integration. So that's the integral, and we can combine this with the earlier integral that we had to get square brackets, a quarter theta squared, that's that one there, and plus all of this, so plus 7 over 4 theta sine 2 theta plus 7 over 8 cos 2 theta, and the limits are from 0 to pi over 2. So 0 pi over 2, and then we're going to substitute these in and subtract them. So we're going to sub pi over 2 in first. So pi over 2 becomes pi squared over 4 and divide by 4. So that's pi squared over 16. And when we put pi over 2 into this term, we're going to get sine pi, which is a 0. So this term disappears. And then we put pi over 2 in here, that gives us cos pi, which is a minus 1. So that gives us minus 7 over 8. Minus, and now we're going to substitute 0 in. So 0 into here gives us 0. Here we're going to get a 0 again because we put a 0 here, it's a 0. And here we get cos 0, which is a 1, so that means it's a 7 over 8. So this simplifies to pi squared over 16, and minus 7/8 is minus 7/4. And that's the answer.